Okay, so to continue the series of sorting algorithms, we're going to be looking at bubble sort now. Alright, so yeah, just a brief overview again. A sorting algorithm is essentially just an algorithm that sorts any kind of group of data or numbers or letters, etc. Some examples that that sorting algorithm has is merge sort, which we've already gone over. Link in the video is available. Bubble sort today, and then there are some quick sort and insertion sort. These are some you might not come into contact with during GCSE, but if you do computer science A level, then these are some ones to definitely be aware of. All right, so what are the steps in order to accomplish this bubble sort algorithm? First of all, we're going to be comparing the first two numbers or the first two elements in the list and rearrange them if needed. So if just for an example we had 1 and 2 to be the first elements in the list, then we wouldn't need to rearrange them, or we wouldn't need to swap them. So we can just look at the next two elements, and then we'll be looking at the second element from the first comparison and the third. Right, so we're actually looking at 2 twice by comparing it against a different element this time. So that's what step 2 is, comparing element 2 and 3 and rearrange it if needed. And we progress to 3 and 4, and then again it'll be 4 and 5, and then 5 and 6, repeating this process. Once we get to the end of the list, so we've compared all the elements in the list, we're going to have to go back to the beginning again, because they still might not be in the right order. So once we get to the end of the list and a comparison has been made, we go back to the beginning of the list. And we repeat this essentially until we haven't made a comparison by when going through the list. So if we went through the list and we realized it is all sorted, there are no comparisons, or there have been no comparisons made, then we can say this list is sorted and we can end the algorithm. Right, so let's look at an example. So the highlighted numbers are the numbers we're comparing. So look at the first one, 3 and 2, we'll have to swap them. 3 and 4 we don't have to swap. 4 and 1 we would have to swap. And then once you get to the end of this little paragraph of going through it, we can see the first pass is completed. So this is what we say when we reach the end of our list first time. And then we do the same thing again, start from the beginning, comparing 2 and 3. Is 2 less than 3? So it is, so we don't have to swap. And then compare 3 and 1, and as 1 is smaller than 3, we will swap. This is the same process we go throughout all of it, and then we get to the end of the second pass, and then we go through it one more time for the third pass until our numbers are indeed sorted. Third pass has been completed. Alright, so let's look at it in pseudocode. Or again, you might not be tested on the actual pseudocode of it, but sometimes it can help to get a deeper knowledge of the content. So at the top we can see all the variables are initialized. And what this just means is we're giving them a value, right? The counter is starting off with the value of 0, swaps the count starting off with the value of 0, and length is equal to the length of the list. And then we have a while loop next, and this while swap or swapped equals true. So while we have done a swap, then we will continue to the nested loop, and this is while counter is less than length minus 1. So it just kind of means that while we are still in the list, right, we haven't gone over the list. We haven't tried to look at the value after the list. And then we're going to be swapping if they're the wrong way around, or if the counter is bigger on if element 1 is bigger than element 2, then we're going to have to swap them round, right? It's that same kind of process of rearranging. And to do this in code, we're going to use a temporary variable. And what this really means is that because we don't want to lose the data we're swapping, we're storing it in a temporary variable and then just reallocating it later. And then the swaps equals swaps plus 1 and counter equals counter plus 1 are just increments. So we're going to the next element in the list, and we're keeping a record of that swap we just made. And finally, we have those last if and else statement. And if swaps equals 0, then swapped equals false. That just means we've gone through the list and we haven't made any swaps. And then we have an else just making it equal to 0. All right, so in summary, bubble sort, what it does is just compare the elements that are next to each other to sort a list of numbers. Again, it could be any kind of data, letters, or you can get into more complex with different kinds of data. So it is a pretty simple algorithm. It's simple, but it's not as complex as merge sort, which we've gone over already again. And this does make it easier to develop and easier to implement, which just means to code. So we do have this advantage, whereas it is not as efficient as some other algorithms out there, like merge sort, like quick sort. So we do have a little trade-off there. All right, hope the video helped. See you next time.